Well, hey there, kiddos. We are going to talk about patterns and sequences, which is not going to be new to you because you have seen this before, but we're going to go over it anyway. So here is your first one. Y'all cannot sit there and laugh at me. Katie and Ricky are laughing at me because I'm making a video. So say hi to Katie and Ricky. Hi. All right. So we're going to take this lovely little picture, and from that we're going to make a table, and from that we're going to make what's called a function rule, which is an expression that we can use to answer the question no matter how many blocks, hexagons, whatever it is that we have. So for our table, on the left hand side we're going to put what we call the term number. It's, you know, what number figure are we on, and then on the right hand side we're going to put the number of blocks. And so lots of counting is getting ready to happen. So the first figure has 1, 2, 3, 4, 5, 6, 7, 8 blocks. The second figure, I'm going to let you count this time, has 10 blocks. And the third figure has 12 blocks. So just like we did in class today with the hexagons, we're going to sort of see what the pattern's doing. And so if you look here, from 8 to 10, we're adding 2, and then from 10 to 12, we're adding 2. And since we're adding 2 every time, that's the same thing as repeated addition, so that means that I get to do 2 times n, and n is going to be the figure number, whatever figure I happen to be on. And so we're going to check to make sure, see if there's anything else I have to do. So if I'm on term number 1, 2 times 1 happens to be 2, but I need it to equal 8. So in order to get from 2 to 8, I have to add 6 blocks. And so here's how they came up with that. These 2 blocks are staying consistent every single time on every figure. And to that, 6 blocks got added. That's where these 6 blocks came in. And so I have to do 2 times the number that I'm on every time. So I have it twice here, I have it 3 times here, whatever, 4 times on the next one. That too is staying consistent, and then these 6 blocks down here never change. So now we're going to determine the total number of blocks when the term number is 8. That just means we're going to plug it in. 2 times 8 plus 6. Well, 2 times 8 is 16, and 16 plus 6 happens to be 22. So the 22nd term number, my bad, the 8th term number has 22 blocks. Worked that backwards. All right, so part B says, well, the term number is 15. Do it again. 2 times 15. Plus 6, which is going to give you 36 blocks. Part C is where we get to work backwards, because now it says, what is the term number when there are 52 blocks? So here's where I plug it in. I know I have 52 blocks. I need to find out what n equals. So now I've made an equation, and we know how to solve an equation. We're going to subtract 6 on both sides. So I have 46 equals 2n, and so then I'm going to divide both sides by 2, and when I do that, I get that n equals 23. So the 23rd figure will take 52 blocks to make. So example number 2, now instead of giving us pictures, they gave us a scatter plot. And so I'm going to talk about what these points are. So the left side of my table is x, the right side is the y value. So I'm just going to start with the point to the furthest to the left and list its points. Its coordinates. So this one right here, the x value for that point is 2, because it's 2 over this way, and the y coordinate is 1, 2, 3, 11, because it's up 11. This point right here, the next point that I have, its x coordinate is 4, its y coordinate is 5. This one, the x-coordinate is 5, and the y-coordinate is 2. And then the last one down here, the x-coordinate is 8, and the y-coordinate is -7, because it's way down here. So now I've got to first figure out my rule. To get from 11 to 5, I have to subtract 6. To get from 5 to 2, I have to subtract 3. To get from 2 to -7, I have to subtract 9, and you will notice that these are not consistent. Every other the problem we did in class today plus this problem, they change by the same thing here. These do not. The reason why is these numbers aren't consistent. So we're going to find these changes as well. So to get from 2 to 4, I added 2. From 4 to 5, I only added 1, and from 5 to 8, I added 3. My goal here is to figure out how much this changes for one of these. Well, they made it real easy for me. Right here, this changes by -3 for a change of +1. And if you look, this change, this -6, changed that much for two of them. Well, if I simplify that, that's a change of -3 for one of them. And then this one right here changed by -9 for a +3, so it went down 9 and this went up 3. So if I reduce that, that's also a change of -3 over 1. So they're all the same. So really I am adding 3 every time, or subtracting 3 every time. It's just hard to see because this isn't consistent. So the thing I'm doing at repeating, -3, -3, -3. If I made this table go all the way through, you'd see that. So my function rule is going to start with -3 in. And then I'm going to test it to make it work. So I'm going to plug numbers in. So -3 times 2 makes a -6. I need to get from a -6 to a +11, which is +17. And so my function rule should be -3 and +17. We're going to check it again. If I do -3 times 4, that's going to be -12. And if I do -12 plus 17, that's going to give me 5. And so that's going to be my rule. So now we're going to check it. So now we know the x value is 12. So I'm going to do -3 times 12 plus 17. Well, -3 times 12 is -36. And when I add 17 to that, I get -19. And so this works out to be -19. And so if I were to do part B, I would do the same thing. I would do -3 times 20 plus 17. Well, -3 times 20 is going to be -60 plus 17 is -43. Now we're going to work backwards. We want the x value and the y value is -61. So I'm going to do -61 is equal to -3n plus 17. I probably should have used an x instead of an n because that's what we're finding, but that's okay. Solve your equation, subtract 17. Stop copying. So I have -78 equals -3n. And then you divide both sides by -3. And so you get that it's 26. So one more, we're going to go from the sequence to a table to the rule, and then we're going to use it. And then we're going to do a couple of pictures. So we're going to plug this in. The first number I have is 18. The second number in my sequence is 23.5. The third number in my sequence is 29. And the fourth number in my sequence is 34.5. So the first thing I do is discover the pattern. What is happening every time? Well, 18 to 23.5 is going to be adding 5.5. And so let's check and see. If I do 23.5 plus 5.5, oh look, that equals 29, so that's the same. And then if I add 5.5 to 29, that's also 34.5. So I'm adding 5.5 every time. So this is consistent. That becomes part of my function rule as 5.5 times n. Then I have to plug it in and test it. If I do 5.5 times 1, it just equals 5.5. I need it to equal 18. So if I take out my calculator, I do 18 minus 5.5, I get that I have to have 12.5 more. So I have to add 12.5 to that. So there is your function rule. That's the way that works. No questions? Let's do a couple more. So now we're going to use our rules. They're just going to give us some, and we're going to write the first 5 terms. There are a couple ways to do this. I need to sneeze. I will only do the first 3 terms because the first 5 terms, you'll get the point after the first 3. Okay, so we're just going to find the first 3 terms, not the first 5 terms, because you get the point. So if I want to find the first 3 terms, that means to find the first term, I'm going to plug in 1. So I have 3n plus 4, I'm going to plug in the 1. 3 times 1 is 3, plus 4 makes 7. The first term is going to be a 7. The second term, I'm going to plug in a 2 because that's the second one. So I'm going to do 3 times 2 is 6, plus 4 makes 10. The second term in my sequence is 10. To get the third one, guess what number I'm going to plug in? Yep, I'm going to plug in a 3. So 3 times 3 plus 4, well, that makes 9 plus 4, which is 13. So there are the first 3 terms in my sequence. Now, the next way to do that, because there is another way to do this, other than to just plug in numbers and go about it that way. There's a completely other way to do this. I'm going to tell you about it and hope you can follow my directions, because I no longer have my fancy calculator on my computer screen that I can show you. But you can take your calculator and plug this in, and it will tell you every term you possibly want. So if you take your calculator and you turn it on and you press the button under the screen that says, oh, you don't want to press, yeah, you press the button on the screen that says y equals. When you do that, you should get a screen that has a whole bunch of y's. It'll say y1, y2, y3, and so on and so on. So next to y1, you're going to type in this equation, but you're going to use x's instead of n's. The x button is right next to the alpha key. There's a green alpha key or a yellow alpha key. Okay, so you have a green alpha key, and just to the right of that green alpha key is this button that says XT. It has a funny looking O and an N on it. That's your X button. So you're going to push the X, and then you're going to do parentheses just like it has right there, and you're going to do X minus 1.5. And you're going to close your parentheses, and you're going to hit plus 2 so that it looks exactly like it does on the paper, only with X's instead of N's. And then to go look at all of the little things that go with it, you're going to press second, which is the blue button. And then you're going to press graph, which is also under the screen at the other end on the right. And that should bring up this pretty little table with all of these lists. And if you look, if you go to number 1 on that list, it's going to tell you that number 1 is 1.5. So the first term in that sequence is 1.5. The second term in that sequence is going to be a 3, because next to the number 2 there's a 3. And the third term in that sequence is going to be 6.5, because that's what's next to the number 3. And we could go so on and so on. So if you don't have a calculator, or you couldn't follow my steps because you couldn't see what I was doing, I promise I will go over it again. You can just plug in the numbers. But your calculator will also help you out. So let's do this next one. So you got a train moving at a constant rate of speed, which means that its speed is not changing. Set its cruise control. The table below shows how far it travels in a given number of minutes. We're going to use this information to figure out how many miles it will go in 45 minutes, and we're going to write a rule. So the first thing I have to do is figure out my change. Well, to go from 5.75 to 11.5, that's a change of 5.75. Well, from here to here, that's also a change of 5.75. And guess what? So is this. It's also a change of 5.75. But this change of 5.75 miles is for a time of 5 minutes. I have to know, in order to write my function rule, what this change is for 1 minute. So to do that, I have to divide this number, the 5.75, by the top number, the 5. So I'm going to divide those, and I get that it changes 1.15 for every minute. So my function rule is going to start with this. For every single minute, I'm adding 1.15. So I'm going to do 1.15 times x. And then we've got to see if there's anything else to do. So I'm going to multiply by 5. Well, that equals 5.75, which is exactly what it's supposed to equal. So that is your function rule. So if I want to know what happens in 45 minutes, I can just get to plug in 45. And it will tell me that in 45 minutes, that train should go 51.75 miles. So one last problem, pretty little picture. Oh, there's actually 2. I apologize. You have 2 more problems. The next one has a picture. So you have these figures that have a repeating pattern. We want to know what the 34th figure is. Okay, so this next one right here, they ask us, they give you this pretty little picture, and they say they want to know what the 34th would look like. And so aside from just drawing it until you get to the 34th one, you can't really make a table. That's not a lot of fun. So here's what we're going to do. Each figure has 5 sides, and I am looking for the 34th figure in this pattern. So I'm going to take the 34, that's what I'm looking for, and I'm going to divide it by 5, because each figure has a thing that's repeating. It's going to repeat 5 times. Okay, because after the 5th one, 1, 2, 3, 4, 5, if you will notice, figure 6, it repeats. So it goes 5, figures before repeating. So that's why I'm dividing by 5, not because it has 5 sides, but because it goes 5 things before it repeats. I'm going to do 34 divided by 5, but I'm not going to do this like you're used to. 5 will go into 34, we know 6 times, which happens to be 30. And when you do this, we're going to go back old school. We're going to go back old school just like we did in elementary school. We're going to go ahead and subtract this and get that it's 4. And so we're going to get that this has a remainder of 4. This is exactly what you did when you first learned long division. This remainder is what's important. This remainder of 4 that I get when I divide, when I divide by 5, when I take what I want and I divide it by how many times it goes before it repeats, that remainder that's left over tells me where the 34th figure is going to be. It's going to be whatever the 4th thing looks like. So if I go 1, 2, 3, figure 4 is exactly what figure 34 would look like. So that is going to be answer choice B. So last one. In the sequence above, the first term is 1, and each term after the first is 2 more than twice the previous term. We want to find the value of t. And so they tell us that everything after the first one, they give us the rule. It's 2 more than twice the one before it. Okay? And so n is the one before it, and we've got to figure out what this value is. What is t? Well, the one before it happens to be a 10. So if I plug this in, it's 2 more than 2 times the previous term, which is 10. And so if I do 2 times 10, I get 20. If I add 2 to that, then I get that t is 22. And I just used what the word said, plugged it in, and got it. And so that is patterns and sequences. We will practice this when you come to class tomorrow. I will see you then.